Okay, so the next thing I want is, okay, so theorem. What if we want to have a lemma? That's lemma, proposition, this sort of thing. Well, we can come over here, new theorem, and let's say I want to have a lemma, so I'll just call it lemma, and then here, lemma. Okay, so I'm going to come down here, and maybe right in between here, I'm going to do the following. Actually, I'm going to switch these around. I realize I also have not done anything with proofs yet. I haven't told you how to do a proof environment, so I'll do that in a second as well. Okay. Okay, so I'm going to have a lemma here. And basically, this is going to be the Weierstrass-M test. Suppose that we have a sequence of functions. Suppose that this is a sequence of functions. Suppose that we have a sequence of real valued functions on an interval. Let's just say on 0 to 1. So sorry. 0 to 1, such that the absolute value of each function is less than some number m, and these mk's converge. So I'll just say it's less than infinity, something like this. Then the sum, this converges absolutely and uniformly on 0 to 1. Okay, so this lemma would be, or can be used here. And I just realized abs, it doesn't know what abs is here, right? That's where the problem is. So let me come up here, make a new command. Actually, let me save this for another video. So I'll just come down here and do, whoops, a vertical bar here. And a vertical bar here. Okay, that's what I want. Okay, there we go. All right, so this lemma would be used to prove this typically. Okay, so now notice what we have here. We've got theorem 1, lemma 1, and theorem 2. Okay, so now we've got different theorems, different lemmas, and they're all kind of being numbered differently. I'll talk about numbering in the next video and how we can kind of change the numbering to maybe I want to have it be theorem 1, lemma 2, theorem 3. Or if I have sections, maybe I wanted the theorem numbering to kind of reflect the sections or whatever. But this is how we can make a new environment called lemma. And you can imagine if I wanted to call this a proposition instead, I could do this. Proposition. Oh. Wow. Am I even spelling this right? I've got issues. Okay, so I'm going to come down here. Just change this to proposition, which may or may not be spelled correctly. I've got no idea. Going to recompile this, and now it says proposition instead of lemma. And really, when I'm doing things like this, for like their labels or whatever they're called, I call this proposition a lot of times, and I call this LM instead of lemma, and this THM instead of theorem. Do whatever you want to do. It's this part right here that comes in the second argument that's going to be what is what is visible here. Okay. Yes. Okay. So now let's say we want to do something like have a remark. Okay. So down here, I want to have a remark. So I could come up here. I could do something like this. Okay, I can come down here and then do and say, the fact that all differentiable functions are continuous I think I spelled this as wrong, but it's not telling me. There we go. The fact that all differentiable functions are continuous, but there are continuous functions that are not differentiable is, I don't know, fascinating. It was discovered. Oh, my wife's calling. Diaper problems at home. The funds of parenthood. Okay. Okay, so I have this plugin that's supposed to help something, and it's telling me that I don't know what it's telling me. Okay, so it was discovered. It was telling me I needed a period. I don't know what this. Anyways, another feature that I don't like. Okay, it was discovered by Weierstrass. Am I saying that W-E-I? Sorry, I have the W-E-I-E-R. Wow. Okay, it was discovered by Weierstrass. I think this is true. I'm not completely sure. I think that's why he proved this, is to prove this thing here. Okay, so it was fascinating. It was discovered by Weierstrass. Okay, so all of this, the point is to show you how you could do a remark. So if I run it, okay, so look what we have here. It's in italics. Now, most of the time, you might not notice this, but most of the time, if you read a remark in a textbook, it's typically not stated in italics. It's typically stated in whatever the normal text of the book is. Okay, so how can we do this? Well, here is where, this is the same document I was showing before. You can use theorem styles. And so there's a package called AMS Theorem that lets you do theorem styles. So I'm going to come up here and add this. Okay, so what I want to do now is I'm going to do a command here. It's called theorem style. And I'm going to put remark here. I can't remember if it needs to be capital or lowercase. I'm going to put this here, remark here. Okay, so now what this command does is it picks a new style, the style of theorem style. So this command is in the package AMS Theorem, and what it's going to do is for the theorems below this, like for the new theorem environments below this, it's going to put it in the style of the remark theorem style, which is defined in the AMS Theorem package. So when I run this, I'm going to get it's going to look different here. It's going to be like the normal text of whatever we're doing. So it's not going to be in italics anymore. It's going to be in the normal text, which I'll just run it and you'll see what it looks like. Okay, I notice other things have changed. That's not bold anymore either. It's italicized instead of bold, so it just looks different. Okay, now similarly, let's say I want to have a definition. Okay, so what does a definition look like? Well, a definition looks different than the theorem as well, right? It's typically going to be in this non-italicized font. So I'm going to come up here and do theorem style. Do theorem style here, and new theorem, definition. Okay, so down here I could have something like begin definition. A function is continuous at a point if, and then you can fill in the dots there. Put whatever you want there. Okay, so now when I recompile this, notice what I'll have: definition 1, theorem 1, proposition 1, theorem 2, so on and so forth. So notice what's happening here is everything is kind of numbered in its own thing. So there's theorem 1, proposition 1. If I do another proposition, just to show you what's going to happen, if I do another proposition down here, this is going to be proposition 2. Okay, so you got theorems. It's going to be theorem 1. The next theorem is theorem 2. Proposition, the first proposition is proposition 1. The second proposition is proposition 2, so on and so forth. Similarly with definition and remarks. In the next video, I'm going to show you how you can do get different numbering schemes as well.